All right, so question 1, the number of individual points scored by Rihanna, Susie, Tina, Ursula, and Vicky in 5 basketball matches is shown below. Who scored the highest number of points and in which match? So you look for the biggest number, which we can see looks like this 8, and that's between J and R. So the match was between, so the match was the player R, Rihanna, and match J. So there you go. Rihanna, match J. Pretty easy, that one. Okay, question 2. 4 teams, blue, green, orange, and pink, played each other in a competition. There were no draws in this competition, and the results of the competition are shown below. And they're just going through that a 0 means a loss and a 1 means you won. Now, it says the letters V, W, and X, what they're missing, so what are the values? So if you have a look at the first one, say V is between O and B. So if we go look at the other combination of B and O, which would be this one, there's a 0 there. So because there's got to be a win or a loss, this must be a number 1. If I look at the other game, say this W, it's between G and O. So if I look at the other combination of G and O, there's a 1 there. So between G and O, there's a 1, so that means the W would have to be a 0. And then the last one, sorry, I'm just going to rub that out, it's getting messy. The last one is X, which is between P and O. So let's look at the other combination of O and P, and that's a 0, so that would have to be a 1. So I found V was 1, W was 0, and X was 1. So that option was C. There we go. All right, the next question, 3. In matrix A, element 2, 1 is 7. The order of matrix is a 3 by 2. So you can start popping it up if you think about it. So it's a 3 by 2, so you're going to have 1, 2, 3 rows and 2 columns. And they said that element A, 2, 1, so that means row 2, column 1 is a 7. If we transpose, matrix B is a transpose of A, so if this is A, then B is going to have just 2 rows and 3 columns like this, 1, 2, 3. And what it becomes is that 7 will become in row 1, column 2. So we're looking for, so they flip around to when you transpose. So we'll look for that one, which there's only 1, which is here. So B is the answer. Question 4, in a game between 2 teams, Hillside and Rovers, each team can score points in 2 ways. The team can hit a full, or they can hit a bit. More points are scored for hitting a full than a bit. A team's total score is the sum of points scored from hitting fulls and bits. The table is shown below. Okay, let F be the points scored for a full and B be the points scored for 1 bit. Which of the following matrix products, so you want to times 2 matrices together, that will evaluate F and B. So if you go back to, this is like simultaneous equations. So really we would say Hillside had 4 fulls plus 8 bits and their score was 52. And Rovers had 5 fulls plus 2 bits and their score was 49. So if we were setting this up matrix style, it would be 4, 8, 5 and 2 times B and F. What have I done wrong there? I've got full first here, so I have to put full there, yeah? So be careful with that. Equals 52, 49. So what I meant there, I had F listed first, then B. So F has to go first here and B there, like that. Now they want to know what the matrix product would be to solve this. So if I was solving for F and B, what it would be the inverse of this matrix times the end one. Now, if you look there, have we got that option? We do, don't we? A, yeah? So we don't even have to type in the inverse because they've left it to the power of -1. So there's my answer. All right, a population of bird feeds on two different locations, A and B, on the island. The change in the percentage of birds at each location from year to year can be determined by the transition matrix. Okay, in 2018, 55% of birds were fed at location B. In 2019, the percentage of birds at location A. So we know when we've got the transition, if we ever want to get the next, say the next state, which is what we call n+1, we can always do transition times the state before. Okay, so if you look here, they've given you 2000, and if we do A and B in 2018, they've given us 55. Now, because it's a percentage of birds, if 55% are at B, the rest of the percent must be at A because there's only one other spot. So that's how I knew that this is 45. Okay, so if I'm trying to find state 2019, what I'm going to do is that transition times the state of 2018, which I've now worked out. So we'll do that on the calc. Okay, so we did that and we find that it is 58 and 42. And remember, this is A and B, and they asked for location A, so the answer is D. Okay, question 6. Matrix W is a 3x2 and Q is a matrix such that Q times W equals W. All right, matrix Q could be, so when you get these ones, I always like to write out what they're doing. So I'm putting it, just writing out what they've said. Now, they've said that matrix is a 3x2, sorry, W, so I'm doing that. Now, once I do that, I know for these to be able to multiply, these numbers have to equal. So I know this is a 3. Now I also know that these numbers come from here and here. So I also know then, therefore, this is a 3 as well. So I'm looking for a 3x3. Okay, so straight away, get rid of these ones. Now I'm down to this one. Now hopefully you can see this is the identity matrix. So remember I said when you have ones on the leading diagonal that it's the identity, and it's like timesing a number 1. So if Q was like a number 1, 1 times W will give W. So that's how I know that this is the answer, because I said we know that if this was like, this is like a number 1 because 1 times W would give W, so therefore identity. Question 7. So these questions are related to 7 and 8. So question 7, cows on a farm are free to move between 4 water sources. The change in the number of cows at each of these water sources from week to week is shown in the transition diagram. Let CN be the state matrix for the location of cows in week N of 2019. The state matrix for the cows in week 23 is given, and the state matrix for the location of cows in week 24 is given. So now, of the cows expected to be at Q in week 24 of 2019, the percentage of these cows at R in week 23. So what you're going to look at, when they're asking you a percentage, so there's got a percentage, so remember I said always write out percentage is percentage equals amount over total times 100. So when you hear the words of the cows expected at Q into 14, that's going to be your total. So of the Q into 24 to 19, sorry. So that means this is my total. So down here when I'm working this out, the total is going to be 2, 2, 2. Now, of these cows, which ones came from R in week 23? So if we go and have a look at R, so R in week 23, we had 24 at R, but we want to know of these ones, which ones came from R but went to Q. So if we go have a look at our transition, we want to go from R to Q, which is 20%. So 20% of them. So if I say 20% of the 240, which equals 48, so that's the amount. So I've got 48 out of 222 times 100, and that ends up being D, 22%. Question 8, this is still leading from the question before. So sheep on the farm are free to move between the 4 water sources, and the change in the number of sheep at each of the source from week to week is shown in the transition. In the long term, so we know in the long term, 635 sheep are expected at S each week. Okay, in the long term, the number of sheep expected at Q in each week is closest to. So if you look at this, we don't really know how many sheep there are to begin with our state. We only know they've told us that in the long term we know what's at S. Okay, so remember when I said it doesn't matter how you break them all up, in the long term they will all settle in permanent spots the way it should be according to the transition. So even though I don't know how many there were in total to begin with, I can say the percentage, and I can say I'm going to create a percentage state. And in total, there would be 100%. And I'm just going to shove them all in one spot because I know when I do the long term, so this to a high power, it will break it up the way it's going to be anyway. Remember, we've done a few questions like that where we saw it. It doesn't matter where we chuck them all in. So just remember, this is a percentage. So I'm going to do that. Sorry, that's a bit not clear. I'm going to raise this transition to a high power, times it by my state, and I'm going to see how they break up in terms of percentage of the sheep. Okay, so let's do that on the calc. All right, so we've got the new percentages here. So in the long run, so make sure we times to a high power times this guy, and in the long term we found that this was 24%, 26%, 18 and 31%. Okay, so we know that we have 31% of the total sheep equals 635. So what we're going to do is we're going to find out what this total sheep is using this fact that we know. So should that equal 1? All right, so someone's saying because it doesn't quite add up to 100, it's 99. It's going to be close enough, so I'm going to keep going and hope that my answers, there's one close, because if you look at the answers, they're fairly apart. So I'll just, yeah, it should, but I'd have to divvy it out somewhere. So let's just go with this. All right. So we're going to go and find out what X is. So we're going to say 0.31 times X equals 635. So you can do solve on your calculator or just divide like that. So if we do that on our calculator, we get 2,000 and 48 sheep in total. So then we're looking at this, we want to look at Q. So Q says it's 26%. So 26% of the 248 will equal Q. So 0.26 times 2048 will equal Q. And if I do that, I get 532, which I'm going to say is close enough to C, okay? And that is the answer. All right, so I'm close enough to do it. So maybe if we changed it to 32, yeah, maybe we get closer, but they're all further enough apart, and they do write the word closest to. So we've done that. Okay, question 1. A total of 6 residents from 2 towns will be competing in international games. Matrix A shows below the number of males and female athletes competing from the towns G and H. How many of these athletes, residents, are from Haldor or whatever it is? So you just have to add up the Haldor ones, so which is here. So you've got 1 male, 1 female, so that's pretty easy. That was just 2, yeah? All right, next question. Each of these 6 athletes will compete in 1 table tennis, running, or basketball. The matrix T and R show below contains the number of male and female athletes from each town who will compete in the table tennis and running respectively. Okay. Matrix B contains the number of male and female athletes from each town who will compete in basketball. Complete matrix B below. Okay, so this is where we've got to be careful, and we've got to make sure we're reading all the data. So the 6 athletes will compete in 1 event only. So if you have a look, we've got to look at what we've got. Say in H, we've got 1 male and 1 female. So if you look, the 1 male's gone here. He's playing table tennis, and there's no female hasn't been used yet. So she must be playing basketball, and there's no males. Now, if I go look in the G, there's 2 males for G, the town of G, or whatever, and none of them are playing table tennis. 1 is running, so I must have another 1 playing basketball. And maybe the last thing was, if I look at the females for G, I've got 2, and there's 1 there, and there's 1 playing table tennis, 1 playing running, so there must be there's none left to play basketball. So there is our matrix. All right, the matrix C contains the cost of 1 uniform in dollars for each of these 3 events: table tennis, running, and basketball. For which event will the total cost of the uniforms for athletes be 1,030? All right, so what you want to look at, this is the cost of table tennis uniform, which is 513. So we might need to use the information on the other page, so I'm just going to go grab it. All right, so with this one, if you look at table tennis, if you look at how many are playing table tennis, you have 2 people playing table tennis, 1 female, 1 male. So that would be 2 times 515, because that's how much a table tennis costs. So if you double that, that is 1,030. So this answer is table tennis. They're not going to ask you, it was probably not going to be basketball, because that was a thing you had to find out. And remember, they don't like consequential marks, so it was going to be either table tennis or running. It's something that they've given you. All right, let's look at the next question. Write a matrix calculation that includes matrix C to show the total cost of uniforms for the event named in part CI that contain things. So you have to, you want to use C, and they want you to show you have to use C, sorry. So if I write out C, 550, 580. Now I want to times, and I want to times it by 2, just this 515. And if you look, my answer, they want the answer to show, that the answer is this. So we end up with that amount. So if you look, that's a 1 by 1. Okay, this is a 3 by 1. So that means I'd have to multiply something before it, and it will have to be a 1 by 3. So here I work out. Now, when you multiply matrices, you go run and you go dive. So these 3 will multiply with these 3. So I only want the first one to have a number multiplied against it, and I want it to do it twice. So then the others I'd want 0, 0. So this is what you should have had. You should have had a matrix set out like that. 2, 0, 0 times the other one. All right, question D. Matrix V and Q are 2 new matrices where V equals Q times C. Matrix Q is a 4 by 3, and it's telling me the elements V11 equals the total cost of uniforms for female athletes at Gillian. So let's just, first of all, they want me to fill in Q. If we look all the way down here, we want to get Q. So let's set up our scenario where we have matrix V equals, and we've got Q times C. All right. So, and they're telling me that Q is a 4 by 3 and C I can see is a 3 by 1. So V must have been a 4 by 1. So I know that, a 4 by 1. Okay, so the answer will give me the total, a 4 by 1. So, and if you look, so we know, I'm just going to put, it'll be a 4 by 1. And they said where 1, 1, so this little element is the total uniforms for females, from Gilligan, okay? And then we have 2, 1 is females again, but from H. So we've got females Gilligan, females H, males Gilligan, males H. So when we go running now, and we can see this guy, these are that this is table tennis, running, and basketball. So if I'm going to, what is going to happen is I'm going to run across and run down, and this is going to give me the total cost for females at Gillian. So I need to know how many, this first row is going to be all the females doing the sport. So it'll be females, and this will be paying table tennis, running, and basketball. So this is females at Gilligan, females at Hadfi, or Hadwar, or whatever, males at Gilligan, males at H. So how many female runners did we have? We had one at Gilligan. We had 1 female runner, and we had 0 basketballs. So we pop that in there. And the last one, we want males at H. So males for table tennis, I had 1. And males for running at H, I had 0. And just to double check, males for basketball was 0 too. So there's that answer there. Okay, the 3 television channels C1, C2, C3 will broadcast the international games what is this, Gillen, whatever, I can't speak. 2,000 residents are at Gillen's, 2,000 expected to change their television channels from hour to hour, shown in the transition. The option for residents not to watch television at this time is also indicated in the transition. The state matrix GO is listed, and it's to beginning, so you've got GO and it's starting at 9 a.m. and just remember this is from hour to hour, the state. And so we can see. So complete the calculations to below to show that 835 are not expected to watch TV in at 10 a.m. So we've got to remember this is 9 a.m. So if we were getting state 10 a.m., we do the transition times GO, which is the hour before. So really, you do this times this one before. So if I wrote that out. Now they're saying show that when you do this, it says show that at C3. So this would be C1, C2, C3, and no TV. So they want me to show this spot here, okay, and that it's 835. So if you look at this spot, I'm in row 3, column 1. So that's what was multiplied to get that row 3 with column 1. So it would have been 0.25 times 100, 0.1 times 400, 0.5 times 100, and 0.10 times 14. So if you add all that up, hopefully it would get to 835. So let's go check that. Here we go. All right, we've done the wrong one. So I'm going to take that back because it says, not this one. It's saying for here, isn't it? No TV, 835. So I would, we want this question, sorry. So we're going to go this one by this one. So it will be 0.15, 0.25, 0.2, and 0.50. That makes sense. That will get to 835. All right, sorry, I've jumped ahead and looked at this guy. So looking at this next question, determine the number of residents expected to watch the games on C3 at 11 a.m. So that's 2 out. That's state 2. So you can do the transition to the power of 2 times the original GO. So if we do that and we just want, when we get that, this will be C3. Sorry, this is 11 a.m. This will give me state 3, which is 11 a.m. and we want C1, C2, C3, no TV. We want this number there. So we'll go do that on the calculator. All right, so we did that on the calculator. We did the transition, power 2, we get 356. That's pretty easy. That's just a transition. You can go step by step or just do the power of 2. Okay, question 3. We've got a new scenario where we're either going from they're either watching on channel 3 or they're not watching on channel 3. So there's our 2 options. Now they've said that there's always expected to be 600 residents that will be watching at C3 no matter what. So that means that what this is pretty much telling us, if people move out of C3, then we must have the same amount from no C3 move in to C3, so that it remains at 600. That's what that's saying. So if we have a look, so now they've set up a transition and they want me to finish off, fill in the blanks of this transition here. Okay, so we can see quite easily that this V, we know this has to add up to 1. So I can see that this one would be 1 minus 0.35, which is going to be 0.65. So I found that. So what I want to work with is probably what they have given me. So if you look at it, they gave me this one here, which was from C3 to not C4, not C3. So when I went from C3 to not C3, it was 0.35%. Now I know there's always 600 here. So what is 35% of 600? And if you do that, it ends up being 210. Okay, so I know which is 210 moved into not C3. So if 210 moved into not C3, I'm going back to this fact. So if I move 210 out, I've got to move 210E. So from not C3 back into C3, I want to put 210. Okay, now I want to know that as a percentage. So if you look, there were 1400 here. So if I want to know that, what is this as a percentage? So if I do 210 divided by 1400 times 100, that'll be a percentage. So what is that? So that ended up being 15%. So I know that it's 15% from not C3. So from not C3 to C3 is 0.15. So W is 0.15 and X has to be 1 minus 0.15 because they've got to add up to 1. So that will be 0.85. Alright, after 5 p.m. the tourists will start to arrive at Jillian and they will stay overnight. As a result, the number of people in Jillian will increase and the television viewing habits of the tourists will also be monitored. Assume 50 tourists arrive every hour. So now we're adding 50 into our transition. Okay, it's expected that 80% of the tourists will watch only C2 during the hours they arrive, and the remaining 20% of tourists will not watch television during that. So if you look, if you do 80% of 50 is going to be, what's that, 40? Yeah. And then 20% of no remaining. So they've given you a state here. So you can see you got C1, C2, C3 and no TV. They're saying everyone's going to go, 80% are going to go here and 20% are going to go here. So 20% of 50 equals 10. And so 0 and 0. So this is going to get added on. So down here, the WM is the state matrix that shows the number of people in each category M hours after 5 p.m. that day, on this day. The recurrence relation is given. So write down matrix V. Well, we've already worked that out. So we've got 0. We know we're adding 40 into there and 10 into there. So that was V. And now how many, and remember this is starting at 5 p.m. and it's going from hour to hour. So how many people are expected to watch C2 7 p.m.? So that's 2 states later. So remember, you have to do it step by step with this one. So you can't do a power trick. So you're going to have to go, first you're going to have to find 6 p.m., where you will do T times, WO. So 6 p.m. will actually be W1, and here is 5 p.m. And then you'll do plus V, and you'll get an answer for what we call is W1, and then you have to do it again where you do the transition, but you put W1 in here, and plus V, and you'll end up with W2, which will be 7 p.m. So we'll do it on the calc. We've typed this in to our calc, and we end up with 396,666, 417 and 621. And then they want me to tell at C2, which is this one, so I write 666.